Hi, welcome to our data acquisition presentations. This is our project SAM Smart Air Measure on Group 7. Our group member is me, Phruek Chantarasittiphon.
I am Paranyu Kittinavakit.
So our background and motivations, because PM2.5 pollution in Thailand has become severely hazardous to public health. The Smart Air Measure SAM project was created to help citizens stay constantly updated on their local air quality conditions by combining real-time hardware sensor data with external weather APIs and machine learning models. SAM empowers users with both accurate historic insights and predictive forecasting. So this is our overall architectures for IoT data ingestion, MicroPython on KitWrite, MQTT for MQTT publish, subscribe protocol, and Node-RED. For backend API, we use Fast API, Async Python REST API framework, SQL Alchemy plus PyMySQL database OIM, and HTTPX for HTTP client for external API calls, and scikit-learn for machine learning model interface, joblib for model serialization. For front-end web app, we use Next.js, React, TypeScript, and CSS Glassmorphism. For data analysis, we use Pandas for data wrangling and merging, and NumPy for numerical operations, Matplotlib, Seaborn for visualizations, and Jupyter Notebook for interactive analysis environment. For our data collections and data source, our primary source, we use CryptByte IoT board by real-time data collection via external sensors. We measure parameters like air quality, PM2.5, and PM10 concentrations, environmental ambient temperature, and relative humidity. For chemical, we measure carbon monoxide. And secondary data source we get from TMD and AQI web API. So our data pipeline, we use KitBright board to uh, send data via MQTT to Node-RED and Node-RED to database of the KU IoT, the MyPHP database, which the university, the department has provided, and we request the API from our backend Fast API, and we also get a request from external APIs and get it into the database and request it again and display it to Next.js web dashboard. So this is our database schema for data integrations of sensor data, and this is for AQI data and TMD data.
For API sharing, the first one is external data proxy. It is a API for get API location. It is automatically detect location via user IP. And environmental intelligence, the first one is weather API. Get API weather. It will fetch data from Open Meteor. And that is AQI API. AQI API. It will retrieve a light air quality index from AQI. The next one is machine learning prediction. The first one of this one is API get API predict latest. It will get the latest sensor from database to predict PM2.5 AQI. The next one is post API predict. This one is like the previous one, but you can edit the data and predict it. The next one is dashboard and data ingestion. API get API dashboard stat. It is to verify the connection between Fast API and MySQL database.
All right, so this is our website. Under this is feature page, the weather and AQI page, which detect the location from IP address. We get data. We do not do anything with the database. We just use backend and request the API from the AQI, CN, and Open Metros to get data of the PM 2.5 forecast and the weather forecast also. So you can see we make the display from the API, we get the data. And the next is just a database connection page. We mostly use this to just see the debug because most of the time we have problem connecting with database due to the user limit of the MyPHP admin.
For this page, it is a sensor data analytic. This one will fit the listed record in sensor data table to predict PM205 AQI. This one predict by random forest, this one predict by linear regression, and this is actual data. And you can also edit this one, and it will change. This is a feature important of model. This one is model comparison between two models. This one is residual analysis of each model. And this one is scatter plot of each feature. We have a CO vs PM2.5, humidity vs PM2.5, temperature vs PM2.5 AQI, and PM10 vs PM2.5. Thank you
Okay,
for watching and listening.
that's all of it. Thank you.